for joining our Maritime Autonomous Systems Group seminar, focusing on global ocean observing system and data sharing. We've had to do this solely online because of the train strikes today have caused issues with getting into London. So apologies for it being entirely virtual. The other thing, just to let everyone know, unfortunately, Katie, our presenter, is ill today. But luckily, very luckily for us, Emma and Louis from UNESCO have very kindly stepped in at the very, very last minute to cover this for her. So thank you very much to both of you. And Katie, I hope you feel better soon. I think you're listening in the background. So hopefully you feel better soon. Nothing else from me to say. So I think I will just hand over to Louis and Emma and let them introduce themselves properly. Thank you very much, both of you.
Thanks very much, Emma. So my name is Emma Heslop. I'm the Acting Director of the Global Ocean Observing System based in Paris. And Louis and I met this morning to, we'll take it in turns across the across this PowerPoint. So I don't know, Louis, do you want to introduce yourself?
Yes, sure. I'm Louis Demine. I'm the Data and Knowledge Management Officer sitting within the Ocean Decade Coordination Unit. This is the team sitting within the Intergovernmental Oceanographic Commission of UNESCO, coordinating the Ocean Decade Programme, which we'll talk a little bit about today.
Great. So we're presenting for Katie, so we're also here to answer questions and I will move through with the presentation. So somebody else has got control of it. I went to press a button and nothing happened. So I need to shout out, change slide. Okay, so we're going to cover sort of two main topics. We got the Global Ocean Observing System, provide some background. Louis is going to talk about the data part of the UN Ocean Decade. I would like to talk a little bit around the GOOS, MTS, NOAA dialogues with industry that is a sort of a relatively new initiative started really in the last year that I think and hope would be of interest. And there are some challenges outlined by Katie, maybe to fire some discussion. So Louis, go ahead. So first of all, let me introduce Katie. And Katie is, she's your lead scientist for ocean research infrastructure. So really the person to go to in the UK with questions or information around GOOS and what the UK is doing in the ocean research and ocean observing sort of infrastructure basis. She's based down at the National Oceanographic Centre in Southampton and has a number of international roles with ocean observing and various related issues. Okay, so you have a visual, you recognise her on the street. So next slide, please. I'm going to talk around the Global Ocean Observing System. Is it? Yeah. Great. So underpinning the Global Ocean Observing System is a strategy that was released in 2019, the GOOS 2030 strategy. And it has at its core a set of 11 strategic objectives. And this is what you see around the globe on the right. And perhaps, what's worth mentioning here, the main goals are around system integration and delivery in green. And this is the core of the coordination that the Global Ocean Observing System GOOS does. GOOS really coordinates across the inputs of all the global networks, across many national systems, regional systems, and even the work of various institutes, really towards reaching the demands of society and fueling the observations that will support various policy mechanisms, perhaps the Convention on Biodiversity and, meeting, understanding the evolving nature of our climate and the ocean's role in that. And so these goals, systems, integration and delivery, building for the future and deepening engagement and impact are really sort of aimed to both develop the observing system, but also highlight the need for the observing system and make the right connections with these policy bodies. But what I want to highlight on the right-hand side, you can see a sort of a value chain. And this is vital because it really underpins the strategy that observations from both satellite and the in situ networks really need to combine and flow through data systems, flow into modeling and assessment. And these are the underpinning of a range of applications for society, that the data winds up in the hands of decision makers through various services and products, and that we need to take a key part of that integration is in integrating down the value chain and working with partners who will deliver these services. So there's sort of a brief run through some of the key drivers behind the strategy. Next slide, please. So how does it work? We have the framework for ocean observing underpinning the Global Ocean Observing System, GOOS, and this is sort of a process orientated with issues that we will be responding to coming in. We have several expert panels that look at the physics, the biogeochemistry and the bioeco, and we work with partnerships for sort of human impacts. Really setting the requirements that's needed from the observing system. Then in the purple box, we have the observations, so where we coordinate across strengthening perhaps data flow, the use of best practices and things like that. Various networks taking observations at different scales and you know, to head off into different applications, but working to integrate across them. And that data flowing into data assembly centres and being assessed for if it's having the right impact, really working towards a fit for purpose system. Next slide, please. So I think I said that we have 3 expert panels. There is also underneath the observation coordination, a coordination group called the Observations Coordination Group. This is a key group that works across the 13 global ocean observing networks. And we also have regional mechanisms, the GOOS regional alliances, that are regional coordinating bodies, sort of linking up various national systems into, you know, looking at the priorities on a regional basis. And then to advance the system, we have various projects. Could be the Deep Ocean Observing System, IMDOS, the International Marine Debris Observing System, etc. So next slide, please. So these are all elements that you might see underneath GOOS, and we're governed by a steering committee. Something that's an easy accessible route into taking a look and is a sort of an outward facing piece of communications GOOS does is the Ocean Observing System report card, and you see a visual from that really showing the data collected across all the 13 global ocean observing networks and where that's located. But the aim of the report card is really to give stories and an insight into what's happening within the ocean observing system as a system, and how the different data streams can combine into applications that support society. So you can go up and download it here. I think it's produced every year, and I think it's a really nice insight into what we do. Here is another view from that report card, and it's talking about, in some senses, the work of the Observations Coordination Group. You can see against the Global Ocean Observing Networks, there are some implementation status areas, and we're talking about how the data is arriving in real time, you know, whether how it's arriving in delayed mode, and whether best practices cover all parts of the sort of the value chain of taking the observation and seeing it into data centers. So this is the work of OCG to bring on emerging networks and lead them towards maturity, so that these are robust, mature networks delivering the data that's needed. So next slide, please. This is a view of the GOOS regional alliances, and I would like to really say that there's been a real resurgence of interest, and I think driven by, you know, the fundamental and growing need for ocean observations to work on a regional basis. And so these are really important components of GOOS. And recently, some of the areas that are really quite vulnerable are activating more strongly towards coordinating on a regional basis. And this is another sort of entry point to working in a region with the Global Ocean Observing System. Next slide, please. So, as I understand, there's some interest in sort of the automated observing technologies. And so we have some slides just around the ocean gliders and the unmanned surface vehicles. But these are examples of, part of the range of networks that exist under GOOS. And so the ocean gliders, well, the glider monitoring is coordinated under a group called Ocean Gliders. Some of you may have come across that, and they really monitor the global glider activity. They share the requirements. They look at generating and streamlining the data flows. And one of the big works that they've been involved in is really to produce one format for ocean glider data called OG 1.0, and a buffer format which is helps the glider data enter into the global telecommunications system, which is the entranceway to having glider data used in weather and extreme event forecasting by the meteorological agencies. So this is important work that's much better to do at some global level rather than every glider operator work out how to do it. And these, as you can see, they really are based on strengthening the system. They have then teams that work into boundary currents, storms, water transformation, ocean health and ecosystems, and how ocean gliders can advance their science in the taking of observations and advance the platform capability and our knowledge and ability to understand the ocean using the autonomous underwater vehicle capability. And in my oceanographic career, I started really working with gliders, so I'm a big fan of gliders as a platform. So next slide, please. And I think there's a strong engagement between ocean gliders and industry, and always has been. The industry has been involved in the ocean glider meetings and things like that. Now, the uncrewed surface vehicles, this I mentioned the Observation Coordination Group. This is a proposal to the Observation Coordination Group that will be discussed next week around whether the uncrewed surface vehicles are interested in sort of developing together as an emerging network to look at their data flows, to really find their part as part of an integrated ocean observing system. So we'll be discussing that next week. But it's a connected but diverse ecosystem. So what might that look like? And some of the areas you can see that these uncrewed surface vehicles that are already being used for ocean observing, they can occupy a unique space and add unique value that can really be a part of where we need to be observing in the future, be it around the placing vehicles in the paths of hurricanes, and also for carbon observations or some of the other sort of key areas where we struggle to get sufficient observations. Next slide, please. So I'm going to hand over to Louis at this point.
All right, thank you very much, Emma. So yes, let's have a quick overview of the ocean decade. So why an ocean decade and how does it work? Well, you may remember in 2016, the United Nations adopted the 17 Sustainable Development Goals for the 2030 agenda. And of course, Sustainable Development Goal 14, which is about life below water, is about conserving and sustainably using the ocean, seas and marine resources for sustainable development. And it includes a series of sub-targets around tackling pollution, overfishing, climate change, and so on. And according to, I think, a study done by the OECD, it also happens to be the least funded of all the SDGs within government organizations around the world. And yet it is one that arguably affects all other 16 Sustainable Development Goals. So realizing the increasing threat to the ocean and the fact that our knowledge is quite limited. We only have measured and monitored and observed really a fraction of the ocean. The United Nations tasked UNESCO, UNESCO being the education, cultural and scientific branch of the United Nations. They tasked UNESCO to develop and implement a 10-year plan to boost our scientific knowledge of the ocean and also to develop solutions to sustainably and equitably manage these ocean resources. So this plan was approved in 2020, and the Ocean Decade program, the 10-year program, essentially started in January 2021. So we've been in the Ocean Decade program for almost 2.5 years now. So how does it work? And the Ocean Decade vision is the science we need for the ocean we want. And in order to achieve this, what we have set up is a framework that revolves around decade-endorsed actions. And these typically fall into 4 categories. So on the left-hand side, you can see that's the bottom rung. And this is where the majority of the science will be conducted. These categories there can be programs. These are global programs that encompass, that will last the whole duration of the decade, underneath which a number of multiple projects will come and really work towards some of the specific challenges. So we have these decade actions generating knowledge and science, and these are there to help us to meet 10 identified decade challenges. So these challenges are almost like objectives. We want to understand and manage and find solutions to pollution. We want to understand the effects of stresses on ecosystems and develop solutions to increase biodiversity and so on. So we have 10 decade challenges to address. 5 of them are thematic in nature: pollution, ecosystems, blue food, a sustainable blue economy, and the ocean climate nexus. And we have 5 other challenges that are more, let's say, foundational around multi-hazard early warning systems, for multi-hazard early warning systems, an ocean observing system, a digital representation of the ocean, capacity development, but also the 10th one, which is all about making a step change in humanity's relationship with the ocean, and overcome barriers to behavior change that are required in order to make this step change in our relationship with the ocean. Underpinning all of these challenges, of course, is the need for open, accessible, and interoperable data, and I'll come to that in a minute. So, excuse me, just switch here. So the decade actors are really collectively channeling efforts and resources towards these 10 key priorities, and it's really an inspirational approach. We're building a movement, right, to lift up and transform the way we do ocean science, but also how we manage and how we deliver information, knowledge, and services to address these ocean challenges. So specifically, challenges 7 and 8 here are on collecting and sharing ocean observations and data, and developing a digital representation of the ocean to assist with decision making. And these are key challenges because they underpin really all the other challenges that we talked about here. So the Decade Implementation Plan, in fact, already recognized at the time that digitizing, accessing, managing, and most importantly, using ocean-related data and information and knowledge will be cornerstones of the Ocean Decade. So a quick snapshot of the Ocean Decade, just to give you an idea of where we are. We've been, as I said, it's been 2.5 years now. We have 47 global programs identified across all 10 challenges, from ocean literacy to pollution to coastal modeling and prediction, and so on and so forth. And underneath these 47 projects, we have 235, underneath those 47 programs, we have 235 projects. And then the other types of endorsed actions are contributions, which are typically in-kind contributions, it could be funding, it could be data, it could be a particular publication, and so on. And then activities are typically one-off activities like workshops, seminars, conferences, etc. All of these activities, all of these actions working towards helping us to meet those 10-decade objectives. We have the other thing I'd like to point out is that we are, in a way, a very decentralized coordination team. Here sitting in Paris, there's only about a dozen people. But what we have is we have set up some entities globally and regionally to help us to manage these the various programs, the research. And these are called coordination offices and collaborative centers. And they typically focus either on a region or a specific challenge. And their role is to make sure that the research, the science that's being done is being optimized. In other words, that there's the least possible overlap between different programs and projects, and that we ensure that resources are spread out in an optimal way. They're also there to help with communicating on the successes of these programs and this research, and also helping with funding, with resource mobilization, right? Because UNESCO is not a funding agency, so we have to go out there and help these programs find the resources they need to actually happen. So that's just a quick overview of the Ocean Decade. If I move on now to the data strategy, and I did mention, right, that it's very clear that data and information and knowledge are going to be cornerstones of the success of this program. So how are we going to manage that? And if we look at the Ocean Decade, the ocean data landscape today, it is quite scattered. There are multiple sources and platforms, but how do we make that all work together? Before I go there, I'd like to talk a little bit about first of all, that these decade challenges and all of this research is really there to help us develop sustainable solutions, right? And these are sort of that top of that value chain in this slide here that Emma was also referring to, the applications, the decision support systems, right? Now, if you look at, if you want to decide whether to go fishing or for a walk, you typically go to your iPhone, look at a weather app, and it gives you that information with a nice map. Well, behind that app on your mobile phone, there's a huge amount of infrastructure data that's being generated, processed, and modeled, right? So typically the end user application is what people is the most visible part of that value chain, but it cannot happen without everything else underneath. So starting with observations and data collection, through the data management and the sharing components, and then of course the analytics, the modeling, and the prediction to extract those insights from the data that can help those decision makers. So for these solutions to work, we really need that infrastructure, and we really need to support that entire value chain, if you will, for that the end user application. So with every endorsed Ocean Decade program, we can imagine that there will be such a solution and possibly such a value chain developed. But what we don't want is to end up with all these different value chains floating around totally unconnected. So this is important enough that we need a focused and coordinated approach from observations all the way along the value chain to that end user applications. And we are doing this by implementing these three of these coordination offices and collaborative centers I was talking about earlier. One of them, hosted by GOOS, is the Decade Coordination Office for Ocean Observing. Another one is a coordination office for ocean data sharing. These two are currently, as we speak, being set up, and we have selected some individuals to start the work and initiate the coordination action. And then we have the Ocean Prediction Collaborative Center, which has been up and running since January of this year and doing some great work in coordinating the various decade actions around analytics, modeling, and prediction. So these coordination offices, as well as the endorsed actions, will work closely with two working groups that have been set up within the Ocean Decade. One is the Data Coordination Group, and this is the group that is responsible for developing the data and information strategy for the Ocean Decade, which has just been published yesterday. I'll give you a little bit more information in a minute. And also working closely with the Corporate Data Group. This is a group consisting mostly of private sector organizations who typically work offshore and collect or own large amounts of ocean data that today is invisible to science because it's locked up somewhere. And so we're working with these private sector companies to better understand what are the barriers for them to share their data, and what are the solutions that we can find in order to really be able to make that data publicly available and help in implementing these solutions. So a quick word on the data strategy itself. So we have a vision that by 2030 we will have a trusted, inclusive and interconnected ocean data and information ecosystem that is globally distributed, and then it's actively used for decision making to support sustainable ocean management. So it's a lot to do with the FAIR principles, is to make that data findable, accessible, interoperable and reusable. And so we have 5 strategic objectives that will help us to reach this vision. It is to develop that digital ecosystem that encourages the data sharing and equitable access to multidisciplinary data. It's to improve the data and information discovery and usability. This is the findability and accessibility part of the FAIR principles. But also that we, as users, can go in there and understand where the data comes from, what quality assessment, quality assurance processes have been implemented, so that we can build that trust in the data and information that's being shared across that system. We want a system that is there to support these decision-making applications, right? So we're going to prioritize digital solutions that support decisions for sustainable ocean management. And then last but not least, in order to make all of this happen, we also need the people. And so we want to expand, empower, and mobilize global communities to and improve that data literacy, so that, when we talk about a data management plan, we know what that means, and we have for all of these activities and projects and programs, we can help to build that and mobilize that global community. So this is the overarching strategy, and what we're working on right now is and this will start this month, is that we need to now figure out the action plan. What are the actions that need to happen? What are the resources needed in order for this, for us to reach this vision? And I want to point out also that we are not trying to build something new from scratch. There are already a number of data strategies out there that we can build on. There's some infrastructure that we can build on. There are some platforms that are already talking to each other and collaborating, and we can build on that. But it's really bringing all of these threads together to build this globally distributed digital ecosystem. Right, and just one last point I'd like to make is that, and this is related a little bit also to the discussion here, is we know that there are huge data gaps in ocean data types. There are data gaps spatially and also temporally. So how do we prioritize? And this is part of the work of that will go on in developing the action plan for the data strategy. But we also have an ongoing process which is called the Vision 2030, and this is helping us to set the ambition, the targets for each of the 10-decade challenges. And part of that work will be to figure out what are the priority data sets and the data gaps and the capacity gaps to tackle pollution, to look at ecosystems and biodiversity, to look at ocean climate nexus, and so on. So between these two initiatives, which are going to be working closely together, we need to figure out what are those priority data sets, data and capacity gaps, and this is something that the community in this call will also benefit from, right? Is where do we need to start? Where are these priority data gaps that are going to help us to meet these challenges? But it's also going to help us in our discussions, of course, with the corporate data group, right? It's very unlikely that they will suddenly turn on the tap and release all of their data, because that would require a lot of time and resources. So they're going to want to focus on a specific types of data set, and we can help them in prioritizing that through use cases, for example. So I think at this point, I will hand it back over to Emma for the rest of the presentation. Thank you.
Okay, so next slide, please. So I'm just going to loop back around a little bit, perhaps feeding off a little bit of what Louis was talking about, and really, what are the connections into industry, and how can we, work better together in order to achieve, the aim of the decade, amongst other things, which is very closely aligned with the aim of the ocean observing system, really to deliver better information to decision makers. And so I just wanted to introduce a piece of work that GOOS has been doing with the Marine Technology Society, with NOAA, and with some industry partners, and really saying, how can we work in a more coordinated way towards growing the ocean observing system, in this case, towards speeding new technology, speeding technology that's appropriate for the observing system. And I think Louis has gone through why we would need to look at this and really think about this as an issue. Climate change and the need to manage our oceans are really huge driving factors that I'm sure people have picked up on and are aware of. I should say that this is my second career. My first career was in the IT sector, and so when I sort of came via studies, etc., into ocean observing, I really looked at this and saw it as a marketplace. But talking with industry, we're involved in many observations every day flow from the instrumentation in the water, but the industry generally, the private sector, doesn't view the ocean observing system as a particularly promising market. And so we really wanted to understand more what were the challenges and what were the opportunities in order to kind of grow that market together. Next slide, please. So these industry dialogues took place in Q3 and Q4 last year and Q1 this year, and were really based around that value chain from observations through to services, and looking at industry's role in each of these, and how we could what were those challenges and opportunities. Next slide, please. The synthesis from these is now produced, and you can have access to the draft report, and takes 4 focus areas: 1, improving the market; 2, societal and government change; 3, collaboration to grow; and 4, market elements shaping the future. So next slide, please. I'm not really going to go into all of these. I really want to give you a flavour of the sort of information, and for me, that they provide real market insight as to what levers are available at international level, also at government level and industry level, to kind of change the dial and grow the private sector part of the ocean observing enterprise. As I mentioned, that ocean observing systems and services are often not seen as a really independent market activity, and that if we could understand more about the market size, and there's the USA Ocean Enterprise Study as an example, that companies would have something to lay on the table of investors and say, this is a genuine market. Certainly for startups, this was some of the feedback we received. that working on aggregation of demand at an international level, really identifying what technologies we need for the future, not what technologies, but what information, and having industries sort of have a clearer target for the information that we need as a larger marketplace, as a global system. We also understood things about the dynamics of the market, that sometimes the scientific funding is too unsustainable, and not only for the observing system, but also this inhibits sensor development and the growth of technologies that are needed. And so this is a message to government that sustained funding is needed to grow the blue economy and the ocean enterprise. So next slide, please. So those were some of the sort of areas. The idea that we really need to work on changing the perception of the observing system as being peripheral, this ocean data, to crucial for weather and biodiversity and all the things Louis was talking about. Next slide, please. In collaboration to grow, one element that came out across a number of the dialogues was standards and what role these could play. But certainly the feedback we received from industry was that a lack of standards doesn't create a level playing field, but that too many standards would inhibit growth. So further dialogue as to what standards would be useful with industry, where, and then to perhaps work with existing bodies for developing some of those standards is one idea that's in play. And we're really looking for feedback on these industry dialogues, how to really work in greater collaboration with the private sector. Next slide, please. And so finally, market elements shaping the future. A lot about the new technologies, and autonomous technologies are clearly one of these. New generations of sensors for biology and biogeochemistry. Also sort of the ocean of things, slightly more ubiquitous but lower cost sensors. This was another area. And the use of AI and this sort of technology into, perhaps diagnosing ocean sound, the ocean imagery. There's many areas that are ripe for work. And the early engagement with commercial partners, maybe from science incubators or whatever, is really important in order to transition technologies robustly to the marketplace. And the importance of finding a skilled workforce, which probably is something that you discuss in this forum, but can, for example, international coordination do something to communicate about this, that the careers for scientists, ocean scientists, can be very fulfilling within industry in terms of delivering real change towards environmental or sustainable solutions in the ocean space, and that industry is part of the actors within this. Next slide, please. So anyway, really to say, get involved, give us your feedback around this industry, the dialogues with industry, and you can access the synthesized paper. Now I'm going to switch gears slightly and say I'm going to don my, I'm going to channel my inner Katie, who had some key messages that she wanted to perhaps form some discussion points, really to for the decade to have a resilient and responsive GOOS. There is an expansion of activity and more is needed. We need more stakeholders involved in the ocean observing system. And how we might get involved with industry is part of what we were covering in the dialogues with industry. But we need to provide some framework of guidance for this. Best practices are important, and recognizing the importance of the development of things like best practice and what this means to have a sustained and critical infrastructure, and that this really helps support governments and regional, national, etc. in the challenges that lie ahead, but that we need to have a dialogue also about how we fund the critical infrastructure that is ocean observing. Next slide, please. In a wish to is a point that's very close to my heart. It needs to be much easier for people collecting data to share it in a way that's usable and findable. The solutions to this perhaps can lie in industry and standards. It certainly is work that the Decade data group and the committee are looking at clearly, and could, something came out of the industry dialogues, how do we perhaps mix some of the public and the private sector datas together to a digital marketplace. And this has to take place in order for more innovation in services using data. It won't all be from the science sector. Industry also has a role to play, or the private sector has a role to play in creating ocean information services, very much like in the weather enterprise. Next slide, please. And really, here we are. It needs to be much easier for people looking for data and to be able to find that. And I would hope to build some levels of interesting services on top of the information that's available. We did a study with the OECD that shows that through the BODC, it was a study for the UK with Medin, the data is flowing into many industry sectors. But I think that we need to broaden that capability, so people's thoughts in that space would also be worthwhile. So I think at Wish 3 we end, and so I will turn back to Emma to see what questions we might have.
Great, thank you very much, both of you. We've had a couple of questions in the chat, but also at this, I just want to say to anyone, if they want to kind of unmute and ask a question or put their hand up, that's also fine too. But firstly, we'll go through the few that we've had in the chat. So the first one was, do the partner countries in the Ocean Decade include all of the G20 members? I'm not sure which of you would like to
All right.
answer that, Louis.
Yeah. Ooh. So the Ocean Decade is currently being managed by a team sitting within the Intergovernmental Oceanographic Commission, and I believe the member states of IOC are how many are there, Emma? I think there's like 100 and some 150. 150. So that's not all the states, but at the end of the day, this is a program that was mandated by the United Nations, which covers almost all the states, including the G20. So yes, they are the states that the G20 are among the states that said yes, we need this program, and it needs to be implemented.
Brilliant, thank you. And the next question was, will the digital representation be open source, and will it be available incrementally when regions become mature enough? Guessing that's Louis again.
Yeah, so that is essentially the goal of the data and information strategy, and I'd like to stress that although this is the Ocean Decade data and information strategy, of course the ambition is that whatever we set up for the Ocean Decade will leave a legacy that endures beyond 2030. Right, the Ocean Decade is an opportunity to transform the way we do things, and beyond just the 2030 deadline. So yes, the goal is for it's not to have a system of systems, right? That's just not realistic. So what we want to do is to build on all these different systems that are out there, connect them in some way, and make the data findable, accessible. If we can make it open and free, that's our main goal. But there will be data sets, I'm sure, that have some sort of restriction. So the idea we're going for is as open as possible and as closed as necessary, right?
Brilliant, thank you. And then there's a question here about kind of the potential issues with sharing data from a kind of a commercial point of view or an industry point of view. So have you come across issues with kind of commercial companies wanting to share data or being able to share data, as opposed to kind of the science community that I guess are kind of more used to this kind of open data?
Right. Yes, for sure. I mean, industry, we see different levels of engagement and commitment and willingness to share. And it can be at different levels. Sometimes a CEO of a company will say, yes, I want this to happen. And then it gets bogged down in different layers within the organization, depending on the size of the organization. And conversely, we also have operational project teams who say, hey, we've collected a whole bunch of data, we'd like to make it accessible. And then, they run into internal barriers with their legal departments, etc. So there are a number of typically technical barriers. For example, the data is not in a format that can be easily accessed or retrieved by the company itself or needs some work. It can be contractual and legal issues. They're not quite sure who actually owns the data. Sometimes the ownership is split between multiple companies in a consortium. Or sometimes they're concerned that there might be some liability associated with the data. What if science starts working on the data and finds something that they are liable for? So there are these concerns. These are all these barriers that we're trying to identify and find solutions. And there are solutions, including for companies who feel that there might be some commercial value still in this data. So how do we deal with that? And it's a combination of things, I'm sure. It's writing things in contractual agreements ahead of the data collection. It is looking at ways to maybe downgrade the resolution of or temporal or spatial resolution of some of the data where it's still useful to science, but maybe doesn't reveal all of that commercial sensitivity and so on. So that is exactly the purpose of this corporate data group, is to talk about these issues. I will say that I think in the scientific world there are also some barriers to data sharing, and I think the incentives aren't necessarily always there. It is very much about paper publications, but what about publications of data sets that we've used, and can we use technologies such as digital object identifiers where we can follow and trace the data that's been used to publish a specific paper and maybe also reference that in future publications? So there are groups that are looking at how to incentivize the private sector to share, but also on the scientific and academic side as well.
Brilliant, thank you. And I guess as probably a follow-on from that, I don't know if you want to add something else, but as purely from a practical point of view, how are the companies or their clients actually going to share the data that they've collected, and kind of who's agreeing the format of that data, and how do we, I assume as part of all the work you're doing, there's going to be a format of how that data will be shared, but I don't know if you can kind of expand on that a bit.
Yes, I mean it's still a little bit early days, but what we are seeing is that what we are certainly encouraging from IOC and from other organizations is for these companies to use as much as possible existing data centers and data platforms to push their data through. So maybe I can give you an example. In the UK, offshore wind farm developers have to provide all of the ocean data they collect to the Crown Estate. The Crown Estate is the entity within the UK that provides the leases to build a particular piece of infrastructure on the seabed. Right? They own the seabed and they provide the leases. But they say, right, well, we'll give you the lease if you promise to provide the data. And what the Crown Estate then does is they work with, for example, EMODnet in Europe. And so they have their own platform, but with EMODnet, they have an agreement where EMODnet can essentially pull the data from that platform and use their own sort of automated tools to put it in the right formats for it to then be distributed through the EMODnet platform. And I think that's going to be a growing trend. The IODE, which is a branch of UNESCO, is also working on a pilot project called the Ocean Info Hub, where we're turning the tables around a little bit, and data owners can actually become data publishers through a series of very simple software APIs that they can plug onto their online platforms, and that would essentially sort of, in very simple terms, catalog the data sets that they have, and therefore make it much more easily findable in the first place. And then the access is another step we'll have to figure out, but at least the data can be made findable that way.
Brilliant, thank you. And I think Katie's also added a bit of a response to that one in the chat as well. So thank you, Katie, for doing that in the background. The next question I've got is GOOS looking to access existing sources of data gathering only, or are you undertaking your own programs to fill in the gaps that exist in the data?
So the programs of the various networks and the requirement setting is all around filling these gaps, right? And so some of the networks have existed for 150 years. The voluntary observing ships, as you know, they've been supplying data for safety of life at sea for a really long time. And others are, you know, such as the unmanned surface vehicles, really looking at grouping together, looking at their data, etc., and finding their niche within the global ocean observing network. We don't really, the aim is really to have an integrated system, right? We can't have one system for climate, another one for biodiversity. You know, we need to leverage what platforms are in the water for a variety of different applications. That's why we work on the requirement setting. So yes, fundamental aim of GOOS is to fill these gaps. I think that the existing sources of data, the ones that are not, much of the data flowing from science is within the global networks, can be found in one way or another. It may not be easy or as easy as it should be, and we have a data strategy coming out to shift that data towards endpoints that can then be federated, so that one access point would give you access to all of those data sets, leveraging sort of modern technology. And that will come online in the next couple of years. But as I mentioned, there is data sets that have been taken by industry, and this is something that Louis has also mentioned. And this has a forward look into the future as well as the past. I can't say exactly, for some of the global policy instruments, we do know what data will be needed because people have been a part of those negotiations. But what data you might need in the future around the siting of a particular wind farm or a particular aquaculture facility or something, there's going to be increasing needs, and we can't know for everything. So I think that having the ability to be able to see historical data in this context that maybe has been taken at different years and different times by industry, and be able to pull that in, or those actors that want to understand these questions, be able to pull in this data and give some historical context to current observations or current modelling output, I think will be really useful. But we need to find, as Louis who's been talking about, a consistent and not too onerous way to do this, so that the data really flows. So partly technology, and partly a kind of reaching some level of understanding and agreement with those holders of data as to what could be a norm that we will adopt. And I don't know whether GOOS would do that, but certainly any data that needs to flow through the systems that GOOS kind of coordinates, this would be obviously more than welcome. So it's a combination of those things, I would say.
Brilliant, thank you very much. I don't see any more questions in the chat. I'm not sure if anybody wanted to unmute and ask anything. Any final questions? We've got a couple of minutes left. Oh, there we go. Are there any issues in using data in the ways discussed that has been collected in a coastal state's water under part something UNCLOS? Do states retain any ownership or say over the use of the data?
So it's a good question. I think that, a lot of the funding, right, is for scientific, for the scientific components of the global ocean observing system is government funded, right? And many of those contracts say the data needs to be made available. So I think in the, I hope I'm answering the right question. I think part 8 of UNCLOS is around the scientific research in coastal waters, or waters under national jurisdiction in one way or another. Often when we talk about this issue, we're talking about foreign vessels, for example, or even unmanned surface vessels or whatever from a foreign state entering your coastal waters. I think if coastal water information has been taken generally by the government, then this is free to be delivered in one way or another, because it's undertaken under these understandings, and it's been funded with that understanding in place. The question comes about foreign scientific research vessels or otherwise entering waters under national jurisdiction, and these are currently this is subject to gaining marine scientific research clearance from that member state. However, we are having a discussion at the IOC and prompted by a number of the networks, and this will be for the IOC assembly later this month, a discussion around what the issues are for networks, because as networks deploy more and more instruments from different vessels, and we perhaps would want to put some other instruments on commercial vessels, for example, to take surface carbon. What are the provisions, and how do we work within UNCLOS, but perhaps ease the situation as far as member states would be willing to allow, to streamline it within UNCLOS, so that observations that are not of let's say national security issues and are undertaken by competent organizations could be allowed in some way or other. But that's a really long discussion, and although as scientists we can see the justification when you put yourself in the shoes of the member states and your rights over your waters, there are many other questions. And so this is something that is sort of under active discussion, I think, for the future of how we work together. But it doesn't stop nations adjacent to each other or where there's regular cross-border ocean observing going on, making agreements between each other that such observations are perfectly okay. And you see that in, for example, regions like HELCOM that have some expedited clearance mechanisms and things like that. So it's a huge topic, but I hope that gives you a few insights into some of the things that are going on in that area.
Brilliant. Thank you very much, Emma. So that's, I think, all we've got time for. Thanks again, Emma and Louis, for covering for Katie at the very, very last minute. And Katie, I hope you feel better soon. Thank you for joining us and kind of adding some bits in the chat as well. The recording will be available afterwards, and I think if you guys are happy, I'll probably share the slides as well with everyone afterwards. So that'd be brilliant. All right. Thank you very much, everyone. Take care.
All right. Thank you.
Bye.
Bye.
Hope Katie gets better soon.
Yeah.
Thanks.
Thanks. Bye-bye.